You know that feeling, right? Trying to track your meals, getting totally frustrated with some clunky app, but what if you could just talk to it? Well, today, we're going to break down Calorie Intelligence. It's this incredible project that uses a whole team of AI agents to make that idea a reality. And get this, it's all happening inside a single Kaggle notebook.
So here's how we're going to tackle this. First, we'll dig into the problem itself. Then we'll look at the agent-powered solution. And yeah, we're diving deep into the actual code for the pipeline and its memory. After that, we'll see how it all clicks together in the final dashboard and wrap up with the big question. Why does this agentic design matter so much?
So what's the real problem we're trying to solve here? Honestly, it's that logging your meals is just a massive pain. We think and talk in natural language, right? Like I had a couple slices of pizza and a soda. But most apps force you to hunt through these rigid forms and endless drop-down lists. Just not how we operate.
And this is really the core of it all, right? The old way is just slow, tedious work. But the agentic way, the way this project does it, it's conversational. It actually understands what you're saying, intelligently figures out the details, and it adapts. The whole thing just feels seamless.
And that leads us right to the solution, a multi-agent system. It's specifically designed to take that messy, everyday language and turn it into clean, structured, and genuinely useful data. I mean, this is intelligent automation, pure and simple.
When you look at it from a high level, the workflow is actually beautiful in its simplicity. Step 1, you just type in what you ate. Step 2, an agent parses that into a nice, clean list. Then, another agent jumps in to estimate the calories for everything on that list. And finally, the whole system stores that data and even gives you some feedback on your goals. Simple, right?
Okay, time to get our hands dirty. Let's dive into the technical stuff and actually look at the code that makes all this magic happen. We're going straight under the hood now to see exactly how these agents are built and, more importantly, how they work together.
So every good project starts with the right foundation, the right tools. For the main agent framework, we're using Google's Agent Development Kit, or ADK. For memory, we're keeping it simple and super reliable with a SQLite database. And of course, for the actual brain power, we're tapping into the Gemini API. Now, one really important detail here is security. Notice how the API key is loaded? It's done securely using Kaggle's User Secrets client. That's absolutely best practice for keeping your secrets safe in a notebook.
All right, meet the first specialist on our little assembly line, the Parser Agent. You can think of this agent as the system's ears. It has one single focused job. Listen to what the user types in plain English and pull out a clean, structured list of the food items.
And check out the code. It really shows you how elegant this can be. The agent is just a simple LLM agent from the ADK, and it's given one single, powerful instruction. Extract only a JSON list of food items from the user message. That is it. That one hyper-focused prompt is the secret sauce that makes it so accurate and so efficient.
Okay, next up in the pipeline is the Estimator agent. Now this one is more than just a language model. It's basically a little researcher. It's equipped with a whole set of tools it can use to go out into the world and find the actual calorie count for every single food item that the parser just identified.
And its process is really robust. First thing it does, it checks a local cache. That's for speed. If it's seen the food before, boom, instant answer. If it's a new food, okay, then it queries the Gemini model to get an answer. It then cleverly extracts just the number from the model's response. And, this is the smart part, if all of that somehow fails, it has a safe fallback, a reasonable guess, so it never comes back empty-handed.
So you've got these specialized agents, but who's in charge? Who's making sure they all work together? Well, that's the job of the orchestrator. Think of it as the project manager for the whole operation. It makes sure the parser runs first. Then, it takes that output and hands it off to the estimator. And finally, it takes the finished result and makes sure it gets saved and analyzed.
And this function right here, this is basically the engine that drives the entire system. The whole process kicks off with this one function, orchestrate meal entry. It's like the conductor of an orchestra, directing the flow of data all the way through the pipeline, from the user's raw text straight through to the final structured data.
But look, an intelligent system can't just process stuff in the moment. It needs a memory. So now, let's take a look at how the system actually remembers what you've entered before so it can give you smarter, more context-aware advice over time.
And this is how that abstract idea of memory becomes something real and concrete. The system's long-term memory is a simple yet super effective SQLite database This one little SQL command you see here creates the table that's going to store every single meal, building up that permanent history for the system to learn from.
Okay, but what happens when that history gets really, really long? You can't just feed it all into the model every time. That's where this really clever technique called context compaction comes into play. The system uses an LLM to periodically go back, read all the older entries, and just summarize them into a short paragraph. This keeps the memory incredibly efficient, but without losing all the valuable patterns from your past history.
And here's the code that actually triggers it. This function, compact, context, and summarize, basically looks for any meals older than 30 days, hands them over to Gemini with a prompt to summarize the eating patterns, and then it saves that new short summary. It's a really elegant, totally automated solution for managing the system's memory.
All right, so we've been deep in the weeds, looking at all the complex code and architecture behind the scenes. Now it's time for the payoff. Let's see the simple, clean, intuitive dashboard that the user actually gets to interact with.
Okay, just take a second to look at this architecture. This is the blueprint for our entire intelligent factory. Everything kicks off on the right with the user's input. From there, it flows into that central blue section, the orchestrator. That's the real brain of the operation. The orchestrator delegates tasks. First, it tells the parser agent to make sense of the text. Then, it passes that structured list over to the estimator in the yellow box to get the calorie count. All the results get filed away in the memory bank at the bottom. And finally, the system uses all that info to generate advice and sends it right back to the UI. It's truly a beautifully coordinated dance.
And this is what all that complex architecture is for. This is what it produces. A super clean, polished user interface, all running right inside the notebook. You set up your profile, you type in your meals just like you'd say them, and you instantly see your progress update on these clear visual charts. All that complexity we just talked about, it's completely hidden, and it just delivers this totally seamless experience.
Okay, so let's zoom out and wrap this up by talking about the bigger picture here. Why does building a system this way, with all these specialized agents, actually matter? What are the big takeaways? I mean, this one notebook is basically a masterclass in modern agentic design. Just think about everything that's implemented here. You've got multiple kinds of agents working together, using both custom and built-in tools. You have a sophisticated memory system, both for the short term and the long term, complete with that clever context compaction. The whole thing is built for observability and evaluation, with agents communicating in a really effective agent-to-agent orchestration. This is so much more than a simple script. It's a genuine blueprint for how to build robust AI systems.
When you boil it all down, what this system really achieves is a fundamental shift. It takes something that used to be a tedious, manual chore and transforms it into an intelligent, almost effortless conversation about your own nutrition goals. And that really leaves us with a pretty exciting question for the future, doesn't it? If a multi-agent system can solve a problem like calorie tracking this elegantly, just imagine what other tedious everyday tasks are just waiting to be completely transformed by this powerful new approach.